Okay. So we'll be on a journey for the next 4 weeks, right? Doing the introductory data analytics professional course. So this course is an introduction and a foundation for data analytics professional practice. So what I mean by that mouthful of words is we're looking to start people that are even beginners in data analytics and get you up to speed with understanding what data analytics entails, what practice areas exist, and what kind of skills are required for those areas. And then we go on to teach actual skills and tools that give you a foundation and take you up to the intermediate level such that you can target a data analyst role, right? And typically we do a survey in like a pre-class before the main course where we just try to find out um, kind of triage the kind of people that come into the program, right? What kind of background they have. And usually anything from a fairly technical to a non-technical background still works as far as you're willing to do the extra work and just get up to speed with things. So this is a 2 hour class, this first class, but this is really going to just be an introductory class to tell us what we should expect over the next 4 weeks, over the next month. So I'll jump right into it. Just give a quick introduction. So my background is like my current work is management analytics. I've worked in data science and engineering as well. I'm quite well versed in decision support. So I've done a couple of roles from planning, forecasting, and some supply chain. I do data analytics and strategy as well. And part of my training is just work, my engineering background, and a master's in management analytics from the Rutland School of Management. And right now, I'm working at TD as a senior business insights analyst. So we do work that spans data science to advanced data analytics and internal consulting as well. And just to make the point at this start, we would also have another facilitator that helped out last time as well, especially for some of the SQL part of things and data visualization with Power BI. So what we try to do is to go through the course, like teaching basic skills and then stretching it to the intermediate level and wrapping up with a project. So a project that's like a um, business case type project. So a practical scenario, something you could come across in your work. And we kind of try to incorporate the different learnings throughout the 4 week bootcamp into the final project. So that's usually the layout. In terms of the structure, so we focus on 4 key areas. So the first is really foundational, part of what we'll be touching on today, right? So data analytics practice, trying to explain, conceptually what data analytics is, how in practice data analytics works, especially in a business context. So I'll be very insistent on applying whatever we're learning to a business school context. Like part of why that would be my training in analytics was in business school, but then beyond that, like analytics is only relevant to the business questions it's able to address, right? This is a very professional focused data analytics program. So everything we do will be tailored, right? Will be tailored towards solving business questions and what the practical everyday implications are of the concepts we're learning, right? We'd also look at like analytics roles and careers. So already helping people that want to work full-time in data analytics start shaping their minds around what kind of roles they could apply to. For those trying to pivot their careers, what kind of competencies you need and how to make that switch, right? And also would highlight a lot like the complementarity of data analytics to existing professionals. So in many cases, increasingly, like everyone is having to do some form of analytics, right? Whether you're working in finance as an analyst or you're working in supply chain or a host of other jobs, right? Many times data analytics comes to bear, business analysts, whatever. So we're also showing how like you could learn these skills that make you stand out and also beef up your profile for, even the jobs you might want to be going for that are not core data analytics roles, right? The next thing we'll do is setting the foundation with introductory statistics. So here we try to cover topics that are relevant, right, to be able to function as a data analyst. So we don't go in too much detail, right, just for brevity's sake, one, and given the span of the class, right? But we touch on the important concepts as relates to descriptive and inferential statistics. Big words, but nothing special, just being able to do statistics and work with data. We'll see all of that shortly. Then we go a bit deep into looking at different tools. So of course, your first contact usually is some form of spreadsheet, usually Excel. We look at SQL, structured query languages, and there we try to go not too deep, but in reasonable enough depth. And the reason is, data is usually stored in some form of relational database, right? That you have to query with some form of SQL language. Right. So almost every organization has some database that has some relational tables, right? So it's really an important skill to be able to get the data out, make sense of it, right? And also be able to visualize it. So the final output usually for management or business consumption will be usually some form of report or a dashboard or a visual, something that's business friendly for decisions to be facilitated, right? So we focus on these key areas. There's also a supplementary Python class, but usually the experience is that we don't have enough time to go into that, but that's also available depending on how fast we're able to go. And lastly, and very importantly, we wrap this all up with a project. So the idea with the project is to have a couple of groups in the class, usually 2 or 3 groups. And so first, that's, different people will have different strong points from all we would have thought. Some people are really big on, visualization. Others, someone maybe, go deeper in SQL, whatever. But usually you would work on a team, right? So we already want to simulate that work environment where you're working in a small data analytics team and you're working on a real life case, a project for usually a week in this case. And at the end, we get to present our findings of the project to a panel. Once again, just the idea here is to have that, business school training kind of feel, because like in real life, you have to present your data analytics findings. When you have an interview, a data analytics interview, usually there could be a case study. It's very common that you have to, do some analysis with some data and present. So we want all of this experience to culminate in you being able to take on a business question, look at the data, and be able to solve it using the skills you've learned. So that's the overview of what we hope to cover. Does anyone have a question? I see something in the chat. Would really appreciate Python classes. Yeah, it depends on timing, right? Because all what I've said already is being covered in 4 weeks. So we'll see how it goes. At the start of next class, I'll take a poll to see just where everyone in the class is in terms of their technical skills and kind of have a better sense on what the split is, right? Between those that are able to rush some of these other topics and to see how far we're able to go. Okay. Yeah, so this is just highlighting like some of the kind of how the class is structured in a sense. So we have classes, where we do like discuss conceptual ideas. We have demos when we're doing SQL, Power BI, Excel. We have class exercises. We have the projects, and we'll have some assignments along the way, right? So let's just be in the frame of mind where we'll have to do some work outside the class because the hours we do here will not be enough to cover. But usually it's like straightforward things. And as far as you're interested and you're in this class, like it's also assignments you would enjoy, and we'll get to discuss the assignments in class. Okay, so very important to know what the learning objectives are. I've kind of touched on some of it already, but essentially three key things to gain an understanding of data analytics, key knowledge areas, skills, and tools. That's how the course is split. Learn foundational mathematics and statistics concepts for analytical practice. So this is just saying the foundation of data analytics is, some math and stats, right? So some people rush into the tools and, they just want to be clicking things and seeing visuals and writing code, but you need to foundationally understand how to think about doing data analytics. That's really what sets you apart. Like you would have an interview, they ask questions. Your thought process around data analytics is very important. And I would highlight that a lot. Because in many cases, you're even able to go and watch some video somewhere, see some of the tools. You can always practice and grow your skill set, but you need that right framework to think about data analytics at the very start, and that's what will lay the good foundation for your data analytics journey. Right. And the objectives for some, it's to just see what analytics career paths there are. Some people are looking to change. Some people are looking to already working in data analytics and are just looking to grow their skills. So the second point is identify career interests in data analytics that match personal skills and interests, and also building interview prep skills. So this last bit kind of comes after the program in some sense. I guess they're usually with Black Force, we organize some individual or group sessions for people that have interviews coming up or want to prep, their resume or, put their data analytics story together and know what kind of jobs or what kind of roles to look out for. So that's more like not part of the core program, but could come at the end. Right. So we're going to touch on some foundational concepts already in the class today. Today's class will be a bit shorter because it's kind of an introductory class, but we'll see how much we're able to cover today. So we'll look at data analytics lifecycle. So there's a typical lifecycle for doing data analytics projects or data analytics work. We'll discuss that. We'll look at career options, and we'll touch on the introductory statistics part if we have time today. So I've said a lot about this already. I'm just on. These are the other portions for subsequent classes. Okay, let me just discuss them a bit. So for the Excel part, are there any questions so far? Questions? No questions. Everyone's happy. Okay. So with Excel, what we try to do is there's a bunch of things I've listed, but we try to go through things like really fast because usually a decent chunk of the class already has experience working with Excel in some form. So we just touch on some of the early things and then rush to discuss, some of the things you'd typically use in your work: pivot tables, sorting and filtering, VLOOKUPs, referencing, matching and indexing. Excel visualizations are quite powerful just because they're really fast, like back of the envelope visuals. If you're doing a more standard reporting solution where people would use repeatedly, then you may be using other tools. But in terms of, a quick analysis to throw into a PowerPoint or a presentation deck, Excel charting is really cool and good. And also, touch arrays and array functions. Usually that's stuff for if you're building like financial models in Excel. There's lots of cool features there that could help. For data visualization, okay, we do the SQL part first on the right after Excel. So here we're just looking at relational databases I mentioned. So the different data definition language, data querying language, the different queries. We teach subqueries, joins, and unions, just how to query data. We don't do so much on inserting and updating data because usually in practice, there would be another team, a data engineering team, a data as a service team that really prepares the data. And the analyst's job is really to query the data. So we do a lot more on queries, subqueries, joins, filtering and sorting, temporary tables, cities, table expressions, and things like that, conditional expressions and procedures. So with SQL, we try to get you really hands-on because you need it. And with your project, you also get to practice. If there's a question, you can raise your hand or drop a message in the chat. I'm monitoring it at the same time. Yeah, this is good. Okay, so this just shows what the schedule looks like for the next 4 weeks. So I think Jumoke might be sharing this with everyone, so everyone just knows when there's class and what to expect in each class. But generally, we have 4 weeks, 3 classes a week. For the data lab classes, those classes are just a bit more hands-on, where we're either going over assignments, or doing like live coding sessions or things that are a bit more hands-on, right? And we could do that in other classes too, so you always have to be prepared. But this kind of gives you the breakdown of what we'll be covering over the program. You can go into details reading this on your own time. Something to highlight here is at the end, we have the final presentation. And usually the project will be due the day before. And I try to, depending on availability, bring a team to have a panel. I think last cohort we had we had a data engineer from Vida. We had a supply chain analytics expert from Amazon, and we had Mahita Bell from Easy Solar. We had a couple of cool professionals to come and give us really useful feedback on not just the technical work that had been done, but also like how it was presented. Like, does this make sense? Is this too much detail? Did you focus on what's important? Just good feedback that helps give you an idea of how data analytics is done and assessed in the workplace, right? So many members of that cohort found it useful. So we've retained that. So yeah, are there any questions so far before we start discussing more substantive issues? Questions? Okay, there are none. So we can discuss some. So okay, no questions for now. Great. So we're just going to look at what data analytics is, how you should think about data analytics, and how the industry is shaping up. So this is really foundational, and I'd like everyone to just, kind of pay attention and ask questions and try and understand, the framing. But this is like, very chill stuff, so everyone should be fine. Right. Let me see, I'm able to see hands raised. So if we could raise hands who has heard these concepts, descriptive analytics, predictive analytics, and prescriptive analytics. Like, who knows what these are or has any ideas they want to share? You could type, you could raise your hand and make a comment. Are these all familiar concepts or are they new? Anybody? Okay, let me frame it this way. If you've heard any of these concepts, descriptive, predictive, or prescriptive analytics, and you know what it is, could you raise your hand? Okay, I see new. Augmented is new. Very new. No question. Okay. Oh, new. We have 8 answers more. So we have 2 hands for people that say it's familiar. 3 now. Okay. I just want to get a sense of how much detail to go into and, how everyone is feeling. Okay. So gotten some feedback there and keeping everyone engaged. So let's discuss this. Okay. So, I call this the data analytics framework. So there are 3 boxes here, or 3 parts of this diagram. So on the left hand, you have objectives. So the middle has like the core different concepts. So descriptive analytics, predictive analytics, prescriptive analytics, and augmented analytics. And on the right, you have some key considerations, like things that are important to each of them. So when you talk of descriptive analytics, usually this, entails analyzing what has happened in the past, right? Someone said tear rubber brand new, nice. So descriptive analytics describes events or data that comes from things that have happened, right? So you're describing processes, data of outcomes that happened. So a typical example would be like doing an analysis on historical sales, right? So you're looking at past sales numbers, past sales data. So that's descriptive analytics. And usually here you have lots of different concepts, which we would go into in the class, but concepts have to do with, what's the measure of center of the data, what's the dispersion, how is the data changing over time? So you have averages, moving averages, percentage change. So really with descriptive analytics, you're trying to describe what and understand what has happened in the past, right? So the objective here is to describe what happened, right? Like sales numbers went up year on year, our sales is going down, or we're losing employees faster this year than we did last year. So things that describe things that have happened already. And when you're thinking about descriptive analytics, some of the considerations that should be top of mind is what data integrity. So given that you're trying to describe what has happened, the data on that which has happened, how reliable is it, right? Because you're building a picture of the past of an event or a couple of events that have happened. So does this data really represent what has happened? So your top of mind is really data integrity. The data you're seeing, is that really the data, right? Your sales number per SKU, are the SKUs correct, right? What's an SKU in that case? Does each item in a bundle, is that a separate SKU or is it total when it's bundled together? So just understanding how the data maps to the real process you're trying to describe is really critical in descriptive analytics. Another thing that's important is storytelling, right? So what's the story beyond just the numbers, beyond the data? Is like, what are the patterns in the data? So you're usually trying to describe a process with patterns and being able to tell that story, weave a story together. So these are some of the considerations top of mind. The next thing will be, given what has happened in the past, we want to predict what is likely to happen in the future, right? So predictive analytics is forward-looking. It's saying, as we know, like human beings kind of build mental models of what has happened in the past and expect that to happen in the future, right? That's why we have biases. So predictive analytics is now saying, okay, we're looking forward to predict what may happen, right? And with what degree of certainty are we able to do that? And this is really key for a business, right? Because businesses are trying to make decisions, right? Based on their understanding of their business context and performance and a bunch of different things, right? And be able to adjust their action. So you want to be able to tell what will happen in the future. And the things you're really concerned about here is predictive validity. So when you say this is likely to happen tomorrow, is it valid? Is it correct? And model accuracy. So accuracy being slightly different in the sense of how spot on is your prediction of the future, right? As we know, the future is about impossible to predict exactly, but how accurate is your model, right? So these are things you're thinking about. For prescriptive analytics here, okay, so I could talk about some tools that you look at with predictive analytics. So you're trying to say what will happen in the future. So in many cases, many of our models, like regression, linear, logistic, are all trying to build some relationship, and based on that relationship with the past, predict what is likely to happen in the future, given a bunch of covariates, a bunch of features, right? So it's like saying, we know something about the past, we've described it, but now we want to know about the future and predict it, given our knowledge of the past. But there's another layer, which is not as commonly used, right? But equally important, and like a lot of values exist in prescriptive analytics, because with prescriptive analytics, you're trying to make a recommendation on a line of action that gives a particular outcome. So it's slightly different from predicting, okay, this is likely to happen in the future. But now you have decision variables or levers that you're trying to influence a particular future outcome based on. And so you're prescribing a set of actions. So many times here you're looking at things like simulation models, right? Or optimization models. So you're saying, what's the optimal way to, let's say, deliver items, right? The salesman problem in supply chain. So to deliver newspapers, for example, to deliver people's groceries, Instacart, like how do you optimize it so that this, right? So usually it's formulated into an objective function where you have an outcome, you have a bunch of constraints, and you're trying to prescribe what to do in order to get a certain outcome. So it's kind of different from predictive analytics once again, but it builds on it. So it's kind of a superstructure, right? Descriptive, understand the past; predictive, we know what's likely to happen in the future; and prescriptive, given all the constraints, given the desired outcome we want, and given the risk, we're able to formulate a course of action, and we know what that should drive, right? So it's planning how to act essentially. And the things here that you're concerned with are, once again, model accuracy, obviously, ethics and attribution. So where you have models deciding, right, on a course of action, the whole world of ethics comes in, right, which is becoming a very hot topic, with all the large language models and AI. Also model actionability, right? So there's no point building a prescriptive model if the recommendations that come out of it are not practical, right? So how practical is that process, is the output of that process? And also augmented analytics, here is just a big container for all the evolving things like large language models and the kind of analytics we're able to do with advanced AI, generative models. And here the main consideration is compute efficiency. And I should have added data availability as well, because these are like super data hungry applications. Right. So essentially, this framework just helps you always fit what your data analytics activity is within this framework, and to know what your objective is and what considerations should be top of mind. So if you're a sales analyst in a company and it's your responsibility to monitor sales patterns and, identify patterns and understand what's happening with your sales month on month, year on year, over a longer time horizon, whatever, you're doing descriptive analytics. And the kind of toolkits you need, many times descriptive analytics comes out, bar charts, graphs, lots of visualization. It's very storytelling heavy because you're trying to explain or describe something that has happened. And with predictive analytics, you start trying to infer what will happen. And that kind of helps with planning, helps with decision making, decision support. And with prescriptive analytics, you want to help formulate a course of action, being able to layer on constraints, and come up with like an objective function where you have different scenarios and you know what each scenario, you can predict what each scenario should, what outcomes it should engender, and finally augmented analytics. So do we have any questions on this framework? Does it all make sense?
Yes, it does.
Excellent, thanks. Okay, cool. So this is really important stuff, and every good data analyst or data analytics practitioner should know this stuff, and be able to think using this framework. Okay, let's go on. Not to spend too much time here. So going deeper into, okay, skip something. Yeah, okay. So let's just discuss a bit what data analytics is. Here I just have a few quick definitions I pulled from here and there. Data analytics involves leveraging data, obviously, to gain insights that answer a business question and uncover some useful pattern or information or inform decision making and strategy. So the key things here I highlighted in black, I made bold. So leveraging data. So it starts with data and being able to use it. Answering a business question. This is where many people that are very technical but not as business savvy miss it, because if your data does beautiful graphs and things and models, but doesn't have any business relevance, it's useless. So you always have to bear in mind the business question and how it's formulated and whether it's answerable with the data. And usually in practice, you're uncovering some useful pattern because you want to inform decision making. So ultimately, the business has a question or some value they're trying to drive, and usually it involves some action that you're trying to facilitate decision making of, right? Harvard Business School had the definition that I thought was cool. Data analytics refers to the process and practice of analyzing data to answer questions. So once again, question, extract insights and identify trends. And AWS on their website, they had data analytics converts raw data into actionable insights using a range of tools, obviously, and processes. And you're trying to solve problems. So the problem solving and decision making, are recurrent themes. So business question, leveraging data, problem solving, decision making. Those are the four key phrases. And, leveraging data, what is data? It's just, different kinds of information with particular formatting and defined properties, right? It's a collection of facts, numbers, words, everything that has information value essentially is data. And it could be lots of different things, right? In different forms, in different formats. So with big data today, just think about how much data and the variety of data that exists, from data collected on social media to transactional data to all the videos you're uploading, sound, audio, text, just so much data all around us. And somehow we need to be able to identify patterns in the data and, help businesses make informed decisions. And in terms of data types, we have qualitative, which are just data that's categorical, right? And we have ordinal. So ordinal is categorical data that's ranked in some form. So like A, B, C, D, there's a fixed order, but then it's not quantitative, like A is A, right? But then A comes before B and so on. Nominal is just unordered categorical data, so like nationality, color, shape. And quantitative data can either be continuous or discrete. So continuous quantitative data is just data that can be subdivided infinitely, right? So like distance, point A to point B is 1 meter, then half of it is 0.5 meters, and you can keep going, right? It's as divisible as the precision of the measuring instrument, let's say. And for discrete ones, it's like an individual, a person, right? It's one person, or if it's not one person, it's meaningless, right? Half person is not a person; it's just a corpse, right? So let's talk about the data analytics framework. So this is a framework that helps question where does structured and unstructured data come in here. So structured and unstructured data is really just about the structure and form that data takes, right? So it's really not, these are the fundamental categories, right, of data. But in terms of structure and unstructured, it's just the form in which data is organized, right? So these are the fundamental categories to know. And then structured and unstructured data is just how the data is organized, essentially. Does that make sense? The person that asked that question. So like formats like, I don't know, video, audio. So ultimately, the way the computer analyzes data, whether numbers or sound, or pictures, it's still with numbers, right? With ones and zeros, ultimately. But then there's lots of conversion that happens to get in that format. But data like audio is unstructured. It doesn't have a fixed, well understood structure, right? Got it? Then give a thumbs up in the chat if you're good. Or if you have more to ask, okay, or you're good. Okay. But that's a good question. Thanks. So with structured data, You have a fixed format, you know the properties of the data, but unstructured data, is not structured in a particular form. But then ultimately, all data falls under these broad categories, quantitative or qualitative, in terms of how the computer uses it. Okay, so the data analytics framework. So once again, you see some of the things we've been talking about in the definition, right? So problem formulation is where it all starts. But there's something interesting here where there's like an iterative loop, because you don't always start, you typically start with a business problem, but not always. Sometimes you explore your data, and out of the data, you see a trend or something you don't understand with a trend. And that could be like what informs a business question. But either way, these two, number one and two, help you form and refine the business or analytics question you're trying to figure out down the line. So whether the problem comes from a question that is generated strictly from the business at the initial, or the question comes out as a result of exploring the data and you're like, oh, we can see that our sales are going down, or our sales every March are remarkably low compared to the competition. What's going on with our March sales? Is there something in our process, something with our supply chain, something somewhere that is responsible for that? So out of exploring the data, you're formulating a business problem. Or you could be coming with a business problem directly. The Bank of Canada has announced a rate hike. How is that going to impact this aspect of the business? So you're coming with the problem directly, and then you explore the data to dig into the problem and refine it. So either way, these two go together, right? One could engender the other. For the next, you construct a hypothesis. So usually you want to approach your data analytics question with some thought, right? Some thought of how to go about digging into the problem, or some thought of what could be causing it, or it may be a shopping list of different factors that could be driving what you're trying to measure. For example, let's say it's a measurement problem. But just to say that it's very typical in the next step to construct a hypothesis or have some idea of what might be the outcome of the project you're about to embark on. And from that hypothesis, your next step might be to have an observational or experimental study. So here you're trying to measure something, an effect, let's say of a particular treatment, or you're analyzing the data. So in this whole part, like you might be building models, you might be doing lots of different things. But the main point here is that you're trying to dig into or test the hypothesis you had on what the answer to the business problem is. By model, by any of descriptive, prescriptive, or predictive analytics. And then, so two things could happen. The results align with your hypothesis, or they don't. If they do, then you're telling a story. So you have the answer to the problem, let's say, and then you have to storytell. Or there's an iterative loop that goes back to construct a different hypothesis based on the outcome of your data analytics work in the middle, right? So formulate and refine the problem, have a hypothesis of what the answer could be that you want to do analytics work on. Do the analytics work, and it either makes sense, aligns, solves business problem, in which case you now have to present it to those that will use the outcome, or it doesn't align and you're going back through the loop to repeat until you're able to solve the problem, right? There's some text here that essentially explains the same thing. The only thing I just want to highlight on this slide still, is the importance of business context or contextual domain knowledge, right? So many times it's really important to understand the underlying business, right? Because many people focus on the data, but don't take the time to understand the underlying processes, that generate the data you're working with, right? So business context is really important, and that's where talking with experts in the field becomes important. So I do analytics for credit cards as well, and prior to working on credit cards, like I knew a credit card just to the extent that you use it to shop and whatever. But there's just so much in credit cards data. So much the data is telling you credit card products, how customers use the data, how you acquire new customers, what kind of credit card customers they are. Like it's huge, right? And then you need to understand the products. You need to understand how people use credit cards, why they use credit cards, what kind of patterns you have. You have people that are gamers, just looking to use a credit card, get the promos and move on, right? There's so much contextual knowledge that helps you be able to do proper data analytics. So that's really important when you're approaching a data analytics problem as well. Yep. If there's any question at any point, feel free to just stop me. So why is data analytics important? All this foundational stuff may sound boring, but it's really good to have to lay the good basis for all the work we'll be doing. So as we know, there's been a massive acceleration in digitization, right? So almost everything we do, think about everything you did 10, 15, 20 years ago by any process that was non-digital, and just how there is a digital equivalent that's almost always the preferred option right now. Whether it's financial services, banking, right? Even education, like everything is like we're on e-education platforms right now. You're learning online, you're purchasing online, you're shopping online, you're doing your banking online. Every single thing right now is generating some form of digital footprint, right? So there's just so much data, and companies have to be able to leverage that data because we're generating such large amounts of data. I haven't even talked about social media and the amount of data and content that's generated there. So that's on the one hand. So there's just so much data and digitization that it makes sense to. I think my PowerPoint is trying to crash. That it makes sense for companies who want to leverage that data. The next thing is firms that have robust data analytics capabilities, right, are being able to leverage that as an edge for their business. Sorry, just give me a second. I need to close. I have too many things running. Okay. So many firms are looking to get that edge, right? If you have lots of business data, you want to be able to leverage it, right? And like there's lots of studies that are showing that firms that are able to hone their data analytics capabilities are having an edge in the marketplace, right? And so for that reason, there's a rush by organizations to enhance capabilities. Every team now wants to have like a data analytics sub team. Every company, is building a new data analytics team, right? So that means two things for you guys, right? It means there's lots of growing interest in the field of data analytics and lots of job opportunities that come with that. And also that data analytics will become more and more a part of traditional jobs. So I see lots of job postings where for a business analyst, there's like SQL, and I even saw somewhere there's Python, there's Power BI, they need visualization, they need statistics, they need this and that, they need SQL. And, for many finance roles, more and more like people are looking towards having people that have core data analytics competences. I can tell you this like for a fact. I've been poached to like finance roles even recently, and they were core finance roles, but they're like, okay, if you're good with data analytics and you have the right business context, like you'll be a fit, right? So the point here I'm making is that these are trends that have come to stay and are growing. So this is a good time, like, to get the skills to either embed data analytics into your current career or job role, or to be switching out entirely, because everyone is jumping on leveraging the data the business generates in some form. Under here, I just pulled some interesting numbers that, kind of reinforce the point. According to a recent study that MicroStrategy did, they're saying cost efficiency are boosted by 60% with applying data analytics. Companies are using, so 57% of companies are using data analytics to drive strategy and change. So almost like before a key strategic decision is made in a company, 57% of the time, data analytics work will be done to validate, some of the assumptions or justify the premise, or like different aspects of the strategies informed by data analytics work. They also said 50% use data analytics to monitor and improve financial performance. So monitoring is a big, big thing with data analytics, which will be descriptive analytics, right? So looking back at analytics work that involves looking at data from the past, right? And I think there was an added outcome from the questionnaire that 71% of global enterprises predicted that investments in analytics would accelerate in coming years, right? So it's huge, lots happening here. So you could read the other trends. There's lots online to check the trends, job trends, and just to position one's career appropriately, right? And also, I made a point here to say augmented analytics. I know we've all been inundated by the buzz of ChatGPT and other large language models and how they're revolutionizing a lot of careers, especially lots of text and research-based careers. So, legal assistants, typewriting, people that are interpreting, lots of very text-heavy things are really being replaced. Many people just have ChatGPT as their office assistant, essentially, drafting and things of the sort. So there's a lot more disruption coming, right? So being able to position oneself properly is really key at this time, right? And one last trend I really wanted to highlight here was self-serve analytics. And you're seeing this a lot in very large companies where rather than have, lots of small dedicated data analytics teams to support different parts of an organization, you kind of have specialty teams, and a lot of the data analytics work is designed on a self-serve basis. So you have managers that are able to use dashboards and Power BI and Tableau and pull out their own reports, get the visuals, answer the small descriptive analytic business questions they want to answer, as opposed to saying, oh, I need to call on the analytics team and wait for a week for them to generate some report. So there's that whole push towards embedding data analytics into what everyone does. So if you're a financial analyst, you should be able to build a dashboard that presents your KPIs, right? You don't have to have like a core data analyst. So a lot of data analytics training is going to be embedded into existing careers and job roles. That's important to note as well. Okay. Right. So is there any question at this time? I'm just curious if people are open to share, like, on their current job roles, like how much they feel analytics has grown, like, over the past 5 or 10 years. Like, are you seeing more and more, like, using, even if it's basic analytic tools, spreadsheets, dashboards, visualization tools? Is there a sense where this is growing? Like, are these trends just on paper, or are people feeling them in their careers so far? Anyone can make a comment or drop something on the chat, or a thumbs up. The thumbs up means yes, it's happening to me, and no thumbs up means, I'm doing the same thing I was doing in the same way in the last 5 years, let's say. Okay, I'm seeing a couple of thumbs up. It's good to have a class where people chip in and talk as well. But if you're enjoying the sound of my voice, I can keep going. So yeah, so for a couple of people, these trends are as I have described, right? So some of the roles, right? Here I have a small slide that just highlights some roles and some relevant data analytics skills, from data analyst to business, BI developer, data scientist, data engineer, machine learning engineer, research analyst, operations analyst. So if anyone has any question on any of the specific areas, like, you can drop something in the chat, or you could unmute and ask. Otherwise, I won't spend much time here. I'll just assume we kind of know what the different jobs are. And some of the skills, I just listed a bunch of things. Um, yes, ID, please.
How relevant is the database administrator to data analytics? Because I know for sure that the database administrator is pretty much in charge of the architecture of the database, the relational database. So how is that relevant to actually analyzing the data?
Right, that's a good question. So less so, I would say. Same with a data engineer. So with a database administrator, like you said, like you're administrating the database, so structuring, building, and maintaining a database. Many times, like part of the issue I've had at work in some cases is when the people that are doing structuring the database are totally or largely detached from the people that will do the analytics down the line, or also detached from the business. Like they make some decisions that don't help things down the line. And many times they're things that are really, really expensive and difficult to change. Right. So for example, in the bank, after you structure certain parts of the database or the data warehouse in a certain way, changing something small could actually cost millions of dollars to change something. And that might be a requirement that people doing analytics down the line really need, right? So being able to have a sense of how business analytics works, although there are some core skills that like are applicable to both, like even if you're a database administrator, you're going to know SQL, you're going to know how relational databases are structured. All that is important, right? But just to your point that they're not doing like data analytics, they're not analyzing the data, but they need to have a sense of the kind of work that's been done in analyzing the data. And that kind of helps them be better database administrators, especially for people that are building databases. I've seen all sorts of like crazy ways databases are structured. And also performance, query performance is also a big issue. Like many times in finance data, for example, dates are not stored as dates in very large relational databases. They're rather stored as integers. So they would give it an integer format where it's like, so February 2023 will be 202302 as an integer, as opposed to using date format. That could be the difference between a query running for 2 hours or 25 hours, right? So in terms of database optimization, it also helps many times to have a certain sense of the analytics work done down the line. But I agree, like different aspects of data analytics are relevant to different roles to different extents. I think someone wrote, thanks a lot for that comment and the question idea. Someone said data analysis is not very relevant in all fields. For me, okay, it's HR, people analytics, and policy analysts using data analytics. Yeah, absolutely. That's a great comment because recently I had a colleague that had come from HR data analytics, and I was kind of curious, like, what were they doing? And trust me, there's all sorts of cool applications of data analytics from like even analyzing text and comments on internal platforms within the company. They're doing like sentient analysis where you're looking at people's mood, the kind of words they're using, how people are responding to different announcements within the company. You're monitoring staff attrition. They do lots of surveys in HR as well. So it's like polling data, the way you hear like QPAC poll or Pew Research polls. Those are largely text-based polls. So you're asking questions or ranking choices and things of the sort. So HR does a lot of that. Many companies have like an annual poll they do of employee satisfaction polls. There's so much data in almost every field now, which is the point I was making. And thanks, Mohammed, for reinforcing that. But yeah, absolutely. Even in HR, there's more and more use of data analytics. Thanks. Any more comments, questions? It's always a richer conversation when everyone's chipping in, eh? Right. Okay. So these are some of the roles, and on the right-hand side, some of the skills. And yeah, so let's just touch on some careers. So before this, and you guys indulge me a bit, like I just want to have a sense. I would have done a poll, but usually I do it like in a separate class, not this one. But I'm just curious, like how many people are looking to switch to data analytics or already working in data analytics or just want to get more capabilities that they would embed into their current career areas. So in my experience, we use data analytics in environmental and ecological space as computational biologists. Great. So yeah, there's just so many areas. And that comment is from Priscilla. So yes, absolutely. Like there. So the interesting thing is before this more recent like standardization of data analytics as a field, lots of different fields have been doing data analytics in different forms. As a matter of fact, data analytics at the core is really statistics, and there's a sense in which the statistics folks feel burned, like their field has been hijacked and renamed, and the computer science folks are running all over it, right? But I mean, I worked I did worked as a reservoir engineer a while ago, and geoscience, geophysics, geoscience, reservoir engineering is very heavy on computational and data analytics type work. Not quite data analytics, but there are lots of things that are really the same, right? And so, yeah, in different fields, different things are transferable. So different people have different plans for the class. Someone says they're looking to switch into data analytics. Someone has targets for marketing analytics. That's a whole big area, by the way. In business school, we did a whole course that was marketing analytics. Like I didn't know there was that much in it, but there is a lot from how to target people, how to target marketing offers. Email campaigns, ad campaigns, people's responses, A/B testing, causal inference. Like there's so much cool stuff happening in marketing analytics these days. Someone wants to add analytics to their BA career. Trust me, it will make you stand out. Like I've seen BAs that depend totally on, there's the analytics person that will do this and that, and some just, gather their requirements, they're analyzing or they're analyzing current state, and they're able to give you a detailed analysis that has numbers, that has graphs, that has like very deep and profound descriptive analytics. And you take those guys over a regular BA any day, right? So there's lots of current BAs that are looking to expand or switch. So I'm happy with the BAs that are being really, and PMs being really proactive with this, because like that's the trend. These days I see BA postings and it's like 60% data analytics. Okay, so great, good stuff there. So let's talk about like a typical data analytics career as well. Some people said they were looking to switch also. So a recommended path would be this. For many people, for some people, they have formal training in analytics. They have a data science master's, let's say, or they have a computer science or statistics or mathematics, economy, whatever background where they've already done some data analytics, or they've trained, like done an advanced degree in data analytics. Great. Is that a mandatory route? Really, really not, right? For many people, they get the core skills and land their first job. So for this class, like this is what I discussed with lots of students in the cohort last year, was learning the core skills, building a portfolio, landing your first job. Example, junior data scientist, data analyst, whatever. Or, for those that are incorporating into their current roles, it will be to add the core skills into it. And then you have a couple of options. For some people, they want to really go deeper, like specialize, because they're in like a niche field, right? If you're in healthcare, like you cannot just jump into healthcare analytics many times. Like you need to have some enter and grow into a healthcare data analyst, like a specialist in that area, or financial analyst. This middle box really also applies to people that are already working in a certain domain and just want to do more and more data analytics within that space. So some people move from just being financial analysts to being quants or quantitative analysts. So that's folks that do quantitative finance, healthcare data analysts. Some people go from working as healthcare folks or in pharma, or they're pharmacists and they want to go deeper, and then they kind of start moving. There's someone that said they were doing, is it biostatistics? Okay, no, that's computational biologist. So you have lots of different like niche roles. So for some people, they're like specializing and going all the way to become like a data analytics consultant in the given fields. For some, they're branching out to do more data science type of role, data science, machine learning engineer, AI specialist. And so they're not going so deep within the domain, like becoming a healthcare analytics specialist, but they're doing like modeling and more AI work. So more math and data science work. And for some people, they're going more, their choice is to go more sorry, my computer shows acting up. Right. So for others, they're looking to manage a data analytics team, right? So mid-level, senior level. Where I work, it's more like you want to become a people manager. So you want to manage a team of data folks where you have specialists, you have data scientists, you have analysts, you have lots of different people. So here on this left-hand side, you're going deeper into the business, like being able to take these solutions, take these capabilities the business has and tailor them towards driving value for the business and managing teams that do the work, right? So there are different directions one's career could take going in data analytics based on your interest and the kind of skills you're gaining. So this is just an interesting chart to kind of show career progressions. And because for me, the perspective is everything you're doing has to add up to some grand plan or strategy that you have, right? It may be a strategy that has different options, but at least you need to know where every step of your journey, career journey, leads you to, right? So you can see I have this chart that just shows you that. So seniority here, becoming like a leader. Here you can go becoming the, chief data scientist, chief data officer, whatever. But it's just the kind of competencies and career growth that you're targeting with each of these verticals. Okay. So here I just saw some cool stuff analysis LinkedIn had done of job postings versus people's profiles. So I just thought I'd share it. So the blue underneath, you have the job posting, and the green, you have people's profiles and how they match. So 73% of data analyst job postings had SQL. So you kind of see how this informs how we've structured the program, because there's no point teaching people stuff that doesn't help them immediately on their career. We want you to be able to draw immediate value. Like that's what Black Force is like built around, right? Being able to give you skills for which you can start drawing value immediately. So that's why you've seen how we've structured the program. Because many people come with like lower or intermediate level data analytics skills. So you want to be able to get that juicy data analyst job or incorporate the knowledge into an existing role. And these are the skills that job postings kind of focused on, right? So SQL, Excel, spreadsheet, and some visualization tool. Hadoop, just with distributed systems. Python, also very relevant. So you kind of see, how we structured the course, and just compare this to people's profiles, like people, this Microsoft Office, Microsoft Excel, data analysis. Anyway, so for the data science role, you see like it kind of flips a bit. It's more heavy on Python. SQL is still this very important recurring decimal because the data is most times somewhere in a relational database and you need to get it out in a format you can use. So SQL always there. So for data scientists that are doing lots of modeling, you're doing your modeling mostly in Python these days. So it makes sense. All the machine learning libraries that you were using many times are in Python. Well, many of the good libraries are in Python, also in R. And data engineers, you see, they now focus more on Hadoop because, so I didn't explain this earlier, but I was asking if anyone had a question, but I could just highlight. So with the data analyst, we've talked a lot about data analyst work. The data scientist, you're doing a lot of modeling. So a lot of predictive and prescriptive analytics. You're also building lots of models, many times machine learning models. Data engineers are really concerned with how you're integrating all the data from the different places they're coming from within the business and without, and integrating them, curating and integrating them, integrating, and orchestrating them into a location that it can be used for analysis. So think about, okay, a good example would be a bank. Even a bank has, they have a web page, they have internet banking, they have mobile banking, they have ATMs, they have branch banking with a core banking application. They have all these different systems. And these are just customer interfacing systems. We're not even talking about internal systems, right? And different nodes within the business need different combinations of this data. So the team looking at new customer onboarding, some customers are joining online, internet banking, some customers are joining in different branches all over. Transaction data, some people are spending on their credit card, some people are doing payments from their bank accounts that interact. There's lots of all these data sources have to be integrated into a particular place. There's also the orchestration. So what's the frequency of getting data from the different sources, streaming the data integrity, converting the data, building and maintaining the warehouse, like the warehouses that are collecting the data, what form are they in? So there's a whole lot. It's such a wide field with different job roles and different specialties, but everything boils down to these foundational fundamentals, which we'll be covering in the course. You need to know these things, and from there, build out your career in data analytics or your competencies in different directions. Someone asked about the schedule and notes. Okay, great. Thanks, Jumaka, for answering that. So going on, yeah, so this is the end of this introduction. So what I hope to achieve with this is lay that framework that everyone in their mind is already thinking about how data analytics as a domain works, how the data analytics process to solve business problems works, how the different aspects, predictive, descriptive, prescriptive analytics work, how you should be thinking about data, kinds of data, and then also how the course is structured, and also careers and skills within data analytics. So I'll take a 5 minutes break just for, bathroom break, drink some water. I try to so dry. And then we'll reconvene in 5 minutes and just do an introduction to the statistics portion. I'll probably just do a few slides and we'll call it a day for today. And our next class will be on Wednesday, and then we'll start biting some meats, right? So, Jamake, I'll hand the class over to you. We'll be back in 4 minutes, so at 9:18. In 5 minutes, 9:19 p.m. Yes.
All right.
All right. So let's do this. Right. So now we've laid kind of the foundation. Okay, Michael has a question. Go ahead, please. Okay. It was just a raised hand. Okay, it's done now. Okay. So now that we've laid that foundation, and please go over the slides, make some comments, do some further reading, think about like what you're looking forward to getting from this course. We'll try to do like a small survey or like have a small conversation before we start the next class. But because we end up like being tight with time, I just figured like let's jump into the next class already. So we're back here, right? So we've done some foundational stuff, careers, analytic roles, blah, blah, blah. Now let's talk some statistics, right? A lot of this is things that are really, really important. Please pay attention to them. Don't just come with your attention to like the SQL class or the Tableau class. Like this is the crux of the matter. You need to know how to do analytics, right? In the end, the tools are just the means, but you need to know what ends you're pursuing and what you're trying to achieve, right? Okay. So in the introductory statistics portion of the course, we're going to be looking at measures of center and variability and statistical inference. We will touch on some causal analysis probably, but this is a bit more advanced if we want to do it properly. But I'll definitely like highlight the concepts just so when you run into causal analysis, how it's used and what it's used for, it doesn't sound strange to you at work, right? And there's a lot of content and material out there to help you learn how to do causal analysis. But just to say measures of center and variability. So here we're just looking at more descriptive statistics. So looking at like how to measure center points or the center of a data set. And variability is dispersion around the center, but we'll talk about that in a bit. Statistical inference, what can you say on a population, on a data population, given a sample that you're able to work with? And we'll touch on that too, so let me just dive right into it. But before that, let's have a short intro on statistics, right? And this just deals with like collecting, analyzing, and interpreting data. And this has been going on for a much longer time than a lot of the data analytics buzzwords and buzz fields that are around today, right? So people have been collecting, analyzing, and interpreting data for as long as data collection has existed, right? And the goal is to be able to extract useful knowledge. Once again, useful, and that always speaks to the business question, the useful, like what's the objective? From large sets of data that can be used to understand relationships, trends, classifications, or make predictions, etc. So there are different ends to which we can put statistics, but ultimately it's collecting, analyzing, and interpreting data. And there are lots of different fields. You know, we've kind of alluded to this so far already. In finance, you have like stock value estimation, accounting data analysis, fraud detection. With fraud detection, we know this is a huge, huge big area, right? What kind of trends and patterns can we see in the data that help us identify fraud before it occurs or when it has occurred? Trading analytics. This is growing and huge, much trickier. Financial analysis. So different areas are applying statistics in different forms and for different purposes. Operations and operations research is a huge, huge field that's been using lots of advanced data analytics techniques. So supply chain analytics is very big. One of the most demanding aspects of data analytics from my data analytics training was definitely supply chain, right? So being able to build those optimization models where you have multiple constraints, multiple variables, and this very tricky objective function that you're trying to optimize, right? Very, very huge. Like we saw the whole supply chain debacle coming out of COVID, right? And what the impact it had. So this is also a very important area. Lots of operations research folks are really high in demand in terms of their skills. Demand forecasting, that's definitely a big aspect of predictive analytics. So something like sales, like how do we know, given seasonality, given what's happening in the economy, given competition, given lots of things, how do we predict what the demand for a particular good or service would be, right? Demand forecasting is really important in resource planning. Think about inventory management, for example. It's really, really connected closely to demand forecasting. because your inventory levels, to have optimal inventory levels, you need to have a sense of the demand you're expecting and the variability around that expectation of demand, right? We have transport analytics, risk and reliability. Many of the folks on this call that come from an engineering or manufacturing background can appreciate this. In healthcare, a huge sector that a lot of data analytics happened with in the past 3 years has been public health and epidemiology. So building those models that are predicting infection rates, spread of a disease, vaccination, and things like that. So more public health related things, and epidemiology, just how diseases are spreading and being managed. Pharmacology is a huge area that's been leveraging statistics for the longest time with drug trials. How do you isolate and identify the effect of a particular drug, especially when you have multiple confounding variables? What I mean by confounding variables is just so people have a certain life pattern and you're introducing a particular drug for a given effect. How do you measure with statistical significance that that treatment is giving you the desired outcome, right? And there's lots of confounding variables because the person may be taking another drug, or their diet, their life pattern, whether they exercise or not, what other substances they're exposed to. There's so many things that could be confounding. How do you correct for that? And how do you measure that between a group that you give the treatment and the other group that you didn't give the treatment? And we'll talk about some of these in passing, not in too much detail because of time, but you get to appreciate some of how that kind of analytics is done. So some fundamentals, right? Once more, we said statistics is collection, analysis, and interpretation of data. And two important areas of statistics to think about is descriptive statistics and inferential statistics. So with descriptive statistics, you're looking at extracting valuable information from data you have on a set or on a population, right? So in this case, the outcomes are really about that sample or that group that you're analyzing, right? So what I mean by this is you're looking at a sample and you're analyzing a measure of center, a measure of dispersion within that sample. But the objective is not to generalize on a broader population. You're just describing properties of that given sample. So it's measures of central tendency, which we all know: mean, mode, median, variability, and distributions. So for example, your temperature is 5 degrees averagely this week. So you're looking at the data sample is temperatures over the last week. What's the average, right? What's the average sales, daily sales for last month? Specific, you're looking at particular sample sets, you're trying to infer or get some useful information that speaks to that data. With inferential statistics, you're looking at being able to generalize and predict or make a broader inference on a larger population based on a given sample. A good example would be, for example, what candidate is likely to win the elections, the Canadian elections next year? You cannot ask everybody that's going to vote, right? So you're trying to infer a broader outcome on a larger population by analyzing a smaller sample. So let's say you're conducting an opinion poll and you're asking people, who are you going to vote for? Is it A, B, or C, right? So in that sense, you're trying to, based on the analysis of a smaller sample, make a broader inference on a larger population. And we'll talk about sample population in the coming slides. But just to think about inferential statistics, being able to predict based on a smaller subset of the data, but make a broader inference. Consumer purchase behavior based on surveys. Like, you want to predict how people are going to respond to a product. You see some of those adverts and emails, ads sent, like, do you want to partake in this survey? Are you likely to buy this product? And they do all those product and marketing surveys, right? it's kind of the same thing. You're trying to infer on a broader population, the whole market or the customer base you have, by analyzing a few or a sample of the broader population. So these are really important things because think about all the problems you're solving in business, right? You're either describing something based on the data you have and analyzing that data, or you're making an inference on a broader population from data you have that will be limited on a sample of that population. So important concepts to have in one's mind as we go along. I think we can skip this. Actually, this is just rehashing the data types we have. Yeah, but okay. So just what I would like to highlight here is, in many cases, the type of data you're working with, like determine or informs the kind of statistical analysis you can do, right? So if you had data on, let's say, color preferences of employees at your company, right? What's the average color preference of your team? You don't know, it's categorical. So the kind of what you can do is the frequency of a particular color, but there's no average color, right? Because it's categorical data. So the point here I'm just trying to make is, as we go along, and part of what we'll be discussing is different kind of approaches to descriptive and prescriptive analytics for different kinds of data, different kind of underlying processes and data. So if you're trying to make a choice of what color we should make the office furniture, and you do an analysis, like based on what are you going to decide on what color to pick, there's no average color. So it's either frequency, and there are lots of other use cases we'll touch on. But just to tell you that the kind of data, the kind of underlying process informs the kind of statistical technique that can be applied to the question or to the data in many cases. Another thing I wanted to highlight here, which speaks to what I was saying earlier of understanding the business context, is something often called in statistics the data generating process, right? So the DGP. When you hear this term, what it's saying is understanding the process that generates the data. So it's always good to think about data in terms of what underlying process generated the data, right? So if you see, let's say, sales data, and it's telling you we made $1 million from selling 200,000 items, right? So that tells you, oh, okay, $5 per item. What do those items mean? Is it SKUs? I made that example earlier. So the SKUs are SKUs like individual units of items, or if I buy a pack of 6 beers, is that one SKU or is it each item? How is it combined? What does it mean? You always have to think about not just the numbers. Oh, nice, I have a CSV file with lots of different numbers. Let me do analysis. Always seek to understand the context within which that data was generated. So the data generating process, because often that's what you're trying to model. Next thing I want to discuss briefly is some basic concepts about population. So I've used population a few times. And your population is just the total collection of all possible units of observation. So like the total scope, what defines the scope of your analytical interest. So like in the case of the election polls I mentioned in Canada, what your population will be all eligible voters in Canada, let's say. So a population has a clear definition, there are boundaries to the data, and the data is defined by the interest, the analytical interest. So if we're looking at likelihood of who's going to win and become the prime minister in Canada, we have our frame there, Canada. So Canada, and then who can vote, because people have to vote for the prime minister to win. So the population is all eligible voters in Canada. So that already gives you the population. Now a sample is a group of select observations from within the broader population, right? So like a subset of the population. For those more conversant with set theory. So sample subset of population, total universe of data of interest. and an observation will be a single unit of data. So in that our polling case, think about it as all the eligible voters in Canada, sample is the people sampled in your opinion poll, and observation is each individual voter and their response. So make sense? Now, why I start here is because something that's really important and that we should really know is how is sampling done? So given population sample observation, how do you get a sample? Now, that's really important because with samples, many times what you're trying to do is many times you're constrained on either gathering data for the population or analyzing data for the population. It's too large or it doesn't make sense in the context to do that. But you want a sample to be able to help you infer with a high level of accuracy the same outcomes or the same information that you would get from analyzing the entire population from the sample, in which case the sample has to be representative, right? So I say, statistical analysis of entire populations is in many cases impractical. So opinions of large groups, behavioral measurements. So think about it this way, you're trying to measure the effect of single parenthood on financial success in kids. It's going to be hard to measure everyone in the population. But so to be able to make that inference, you have to take a sample, a subset of all the people that would fall in that category and analyze them and come up with the conclusions. And this solved largely by sampling. Now, there are different kinds of sampling, right? So look at the diagram on the bottom right here, where I haven't been in presentation mode all the while. Nobody said anything. Is it better? Okay, so look at the population, right? And then look at the sample. So you're trying to get a sample that's representative of all of the variability within the population, or the variation within the population, right? And they have different methods, random sampling, where random observations are selected. So that randomness, we expect to capture all the different groups within the population without any bias. Very important. There's also like stratified sampling. So stratified sampling would work if you sorted the population into frames. So let me give you an example. If we had a population of, and typically this is done in like many political opinion polls as well, where you have, this candidate is favorable with women, with college-educated women, with blue-collar workers. So many times when you're trying to come up with some of those kind of samples to make those kind of inferences, you stratify the population. So you're saying of all the population, if there's 1 million persons, you might have 30 women and 70 men, or 70 women, 30 men. You might have 40% are college educated. Like there are different sections, and there's also intersectionality within those, right? And many times you could want to stratify and then sample within each subset, so that within the women group, you have a random sample. Within the male group, you have a random sample. And so you're stratifying by sorting first and then random sampling within that. So that's stratified sampling. And you can already see why that might be desirous to do. So you're breaking the total population into homogeneous frames, subframes, and then random sampling within them. You have cluster sampling, where you're breaking down into clusters, and especially where there's a lot of geographical disparity, you get this interconnected clusters and you sample within those. And there are lots of, like, sampling is a whole thing in experiment design, but just to already make you think about the fact that in some cases you won't be able to work with an entire population. I had to work on a project once that involved like transaction for over 8 million customers. Now, just for the size of like working with the entire data didn't make sense at some point. Now we had to random sample, right? And take a smaller subset that's more that we can work with in a way that makes more sense. So many times you have to do those kind of samplings. And there are more complex ways to sample, but always remember it has to do with what your objective is, right? But so sampling is very critical when you're looking to get a small population and be able to infer on the larger population, doing your analysis and sample instead. Okay. Are we following so far? Any questions? Do you want more explanation on any area? I want to be sure we've not lost everyone. Nobody's sleeping. Is there any questions so far? Like, does it make sense to everybody? Thumbs up, clap, emoji, just do something. Okay, great. Okay, there's a question. Fantastic. Please ask.
Hi, I just want to find out, is there a way to determine what like sample size is enough? So if you wanted to test like 1 million persons, maybe 10 people asking 10, is there a way to determine what's enough?
Yeah, that's a very good question. Usually it depends. So there are lots of different rules around sampling, right? So most times you have to, there are rules of thumb, there are also statistical rules, and you have to be able to choose a sample that's large enough for it to be representative. So two things are important. So on the one hand, the sample size needs to be large enough for the analysis you're doing on the sample size to make sense. So if you've done lots of statistics, you remember when you're doing hypothesis testing and you have all those Z-score, T-stat score, those scores that tell you, is it possible that the hypothesis I'm concluding on is just as a result of chance? Like out of 1 million people, I pick 10 people. It's possible to have all women. If I pick 100 people, it's much less likely. Like the smaller the sample size is, there's a lot of noise that could be introduced as a result of just mere randomness and chance. You could have lots of wrong conclusions or wrong inferences rather. So yes, that's a very good question. There are lots of rules around the size, the sample size to pick, and for different kinds of analysis essentially. But yeah, that's a good question. You cannot use the same size for every size of population and depending on the kind of analysis you're doing as well. Any other questions? Someone said all good. Do you have an additional comment? Okay. And just to add, many times you might be doing a study, right, where you have to adjust the sample size based on like variability within the population. So within the sample rather. So if you know you're dealing with a high variability occurrence or phenomenon, you would adjust your sample size accordingly. So it also depends on the kind of process. If it's a fairly homogeneous, fairly well-distributed, consistent population, you might be able to get away with a smaller sample size, right? So there are different levels of considerations, right, around your sampling, but that's a very good observation. The sample size is very important. And helps determine whether or not you can make the inference you're looking to make. Right. Any other questions? Okay. What's the time? Okay. So let's quickly just touch on this. Okay, someone has a question, please go ahead. Dorcas.
Thank you. I was just wondering if there is a formula to this and if it's something that we can know, because I've been just guessing, because we're talking about a bit of error, that when it's small, it can be error, when it is large. Is there something standard like a formula that one can follow?
Yes, there are formulas and approaches. There are formulas and approaches. There's a Z-score sample size formula. So using your Z-score, there are different different ways to go about it. Like putting a formula here, doesn't fit the purpose because you have to talk a lot more about sampling as opposed to just throwing the formula. But I could send you a reference paper that if you want to go deeper on that, if you've done some hypothesis testing and you want to really figure out how to sample, how to get the accurate size. But I must assure you that it's part science, part art. But yeah, there are lots of rule of thumb formulas that help guide on the population size. But you have to remember that it depends on the kind of process you're sampling and how accurate you want, or with what degree of confidence you want to be able to make your inference. So you have what you call the confidence intervals. So the size of sample you need for a 95% confidence interval is very different from what you need for a 99% confidence interval. And what that just means is that you have a 1% probability in getting your inference wrong. Like you want to be right 99% of the time or 95% of the time. Your tolerance for the confidence around your estimates. So we're going to talk about point estimates down the line in the course, but not to go into. I want us to understand the concepts without going into too much statistical math that bores people. But I can always provide like an abundance of references for you to go and like get the different. There are lots of papers that talk about how to size your samples, but then just understand conceptually that it depends on the objective, the amount of confidence around the estimate you're trying to get from the population, and the kind of the distribution within the population. Those are the things that would inform. But then there are lots of formulas and different approaches, but it's not a one size fits all. Who asked that question again? Was it Dorcas? So if I need to reach out to you,
yes, please. Yes,
okay,
I would like the material. Thank you.
Sure.
Thank you so much.
No problem. Great. It's really cool when you guys ask questions and contribute. So let's keep that energy. Okay, so let's do this last slide before we call it a wrap for today. And please, let's go back and revisit these things. Like, just you take tomorrow's, we have a class tomorrow, we have one on Wednesday. Take tomorrow to just, brush up on your basic statistics, just play a YouTube video, mean, mode, median, just play around with those, just let them come top of mind. In the end, they're very straightforward things that, we're going to touch on and do some examples. So bias exists when the statistic or property being measured by a sample differs materially from the population. So what this means in a nutshell is you've taken a sample out of the population and you're estimating a property of the population. Your bias is how much that estimate differs from the true property within the population. So is a systematic variation in the property being measured from the population or the objective against which it's being measured. So quite straightforward. If you are measuring average height of Nigerians and you take a sample and the average height is really off because you've oversampled short people, that's a bias. So that bias is that systematic variation or deviation of the sample measure or estimates from the population through value of the property. Variables. So I'm just defining some basic concepts. So as we use them along the way, they're not sounding weird. A variable is a given feature of interest that's measurable and takes on different values. So the variable just has to be quantifiable and it's just a feature of interest. Age, height, nationality, sales, whatever, lots of different things. But a variable is it has to be measurable. You have discrete variables like finite numbers, you have continuous variables, all that's straightforward. A statistic is just a value associated with a property. So if you measure the mean or you measure the variability, the standard deviation, you usually just call it a statistic, right? So a certain value associated with a property that you've measured. Data can be organized in different forms. Usually all the data we'll work with in this course will be tabular data. all right? Data that's organized in this form, where you have some attributes or columns, right? And you have records or entries or observations, and you have a unique identifier. Sometimes not unique, depending on if the table is in standard form or not. But the point is just to say, like, a lot of the data we're working with will be raw data, which are records or observations, and attributes or features or columns. So look at the table on the right, you have your staff number or staff ID. So each row identifies a particular member of staff. You have properties or attributes or features like your name, your position, sex, date of birth. All those are attributes of the staff. So the row is the staff, the attributes are the columns. So most of the data we're going to work with, most of the data in relational database is structured in this way. So when you hear attributes, features, columns, usually where you're looking for them is in the columns of your data, and each observation is a row. Let's see. Okay, let me do this last slide so that we just start talking about descriptive statistics, measures of center, when we see on Wednesday. So missing values, just basic, straightforward stuff, but can be important in some way. When you have data entries that are absent, that's a missing value. And missing values are kind of different from zeros, which many people replace missing values with zeros wrongly. But what's to note about missing data? And in practice, at work, with real life data, you're always going to come across missing values and nulls. So you need to think about how to think about them. That's why I just added this segment. I also had an interview once where this was one of the main questions I was always asked. What do you do with missing values in your data? You have a data set with missing values. And they were just trying to test your framework about how you think about missing data. And I just developed these 3 key points, which is sometimes missing values or missing data has something important to say about the data generation process. You remember the DGP? So a field with lots of missing data could speak to something about how the process was handled. So if it's a survey, for example, and there's a particular question in your questionnaire that wasn't clear, and people just always skip and don't answer that. So that lack of data completeness kind of tells you something about the process so you might want to evaluate effectiveness of questions or intelligibility of questions, or how straightforward or understandable questions were based on what percentage of questions are unanswered or the amount of missing data. So in that sense, you see missing data is already information in itself, as opposed to just missing data. So rather than handling that with filling the data, maybe you want to be able to count how many rows have missing data for a particular column, right? Another way to think about missing data holding useful information might be a question that's sensitive and people don't want to answer, right? So you have sometimes questions where people don't know if the survey is truly anonymous. You have that a lot in offices where they say, oh, we're not going to do anything with the data, just answer honestly. And then for some questions that are very sensitive about the boss or the leader, and people don't want to answer. So that could be telling you something about the culture, in that company with HR data, for example, when you're analyzing surveys. So everything could have information value. Always think about data analytics in terms of information value. Missing data in itself could be telling you so much. It could be pointing to data quality or collection efficiency. If you have lots of missing data in a survey where field workers go to collect data, it could be that they're not well trained, right? Or the missing data may be distributed based on who did the sampling. Like if you send agents into the field, you could, based on amount of missing data, evaluate their performance. So there's lots of things with even missing data. And so you have to always think about what field, and if you're asked this in an interview, it depends on what fields are missing, what the data generation process was. And you can go on to highlight these scenarios. And trust me, your answer will stand out, right? And in terms of how you handle missing data, there isn't a one size fits all. It's always valuable to know that and to mention it, right? So in some cases, you want to replace the data with the mean. So if it's a process that's fairly evenly distributed, and we're going to talk about distributions on Wednesday, but if the distribution is uniform, replacing with the mean makes sense, or it might be skewed and the highest occurring data point or the mode might be better to put in. The data might have a trend, in which case the nearest neighbors, you could use k nearest neighbors to fill in the data with the next 3 neighbors. Depends on how the data was collected, what kind of data it is. So you always have to think about it in those terms. Or regression. So regression, you're looking at what the missing data should be given other covariates or given other columns. So a typical example would be, let's say you had a table with data on a column that had high blood pressure or not, where it's 1, they have above threshold blood pressure, when 0, they have none. And you have other things like weight, like age, like sex, like, lots of variables that would clearly predict what that missing value should be. And then you have that missing data. You can fill it in by regressing on the other factors. Could be a case where 90% of the people that have age 85, male, above 250 pounds, with a history of diabetes are going to have high cholesterol. And then you can always use regression filling missing data. Sometimes you just leave them empty. It depends on what you're doing with the data as well. Like some models handle missing data very well, decision trees. Some don't. And so it depends on what you're doing with the data as well. You might need to leave them or delete the entire field. Usually, if you have lots of missing data, right, in columns that are really important to your analysis, you may want to just take out those rows. You may be doing an analysis on a large population, large sample, and in which case taking out some rows doesn't really matter, as opposed to keeping it and having problems. So this is just an add-on to help us be able to answer this and be able to deal with missing data in real life, because with real life data, you would always have missing data as an issue. I also mentioned outliers. This occurs like when some data points that are extraneous, far from the norm exist, right? How do you handle outliers? So it's always important when you have sample of data that you're working with to kind of identify what numbers lie outside the norm. So sometimes you could be working with age data, right? And we're going to talk a bit about different measures of center and measures of dispersion and how sensitive they are to outliers. So imagine if you were doing an average of age of students in a class, and there's a class of 1,000 students, and in your whole data, like there's a number somewhere that's 560. Right? You can already tell that's an outlier. So if you did a distribution that would be sticking out as a sore thumb somewhere in the extreme, definitely we don't have any humans that are 560 years, right? So it could be that an extra 0 is added and there's 56, or it's just an erroneous data point altogether. So it's always really important to look out for outliers, especially in real life data. You're always going to see lots of outliers. And that's why I'm taking the time to just keep us sharp on all the things that in practice, in real data analytics work practice, you're going to need to be looking out for. And there are different ways to identify outliers, some of which should be looking at quartiles, interquartile ranges, standard deviations from the mean. And there are different ways. We'll talk about them in more detail in the class tomorrow. But yeah, I think we're at time actually. So I thought the class would be shorter, but I just felt we should add on and start the introductory part of the statistic portion. Does anyone have a question or any comments so far? Anything they need clarification on before we wrap up for today? Any questions? Well, the concept's clear. Any examples on missing data and how you dealt with it, or any questions on how to deal with a missing data scenario? No? Okay. I think we're probably tired after 2 hours of intense classes, but yeah, it was nice having everyone today. I hope we're able to go back and take a look at some of what we've covered today, right? Yeah, and we'll take it up from here on Wednesday. In the meantime, please try and read up and refresh your mind. A lot of all the things we're looking at here have been done in like high school math and statistics, or early university math and stats. So let's just try and brush up and be ready for Wednesday. All right, thanks everyone. Jumoke, I'll hand your class back.